Yes, the project Trineflex is about transformation of energy-intensive process industries, and this is going to be done through the integration of energy process and feedstock flexibility. And here I'm going to talk about a demonstrator case where we are building a demonstrator for solar and heat pump assisted carbon capture and storage process. So short to the agenda, first I'm going to give you an introduction to the Trineflex project by giving you a project description, showing you the work packages and method that's going to be used, and continue with talking about the task description we actually have with the demonstrator. And I'm going to show the rough idea of the demonstrator and continue a little bit with the different technologies that are part of it, and also talk a little bit more specific about excess heat recovery in the carbon capture process, what heat pump is doing, and what actually a photovoltaic thermal system is doing, and how it looks like. And as you can see, Trineflex is a rather large project with many partners, funded by the EU here. And we at SINTEF, we sit up here in Norway. Yes, so the project description, as already mentioned, Trineflex main goal is the transformation of energy-intensive process industries by implementing energy process and feedstock flexibility. And Trineflex itself is there to develop the toolbox, which is also called Trineflex, to especially fulfill this goal. And so this toolbox will contain digital services for the collection management and real-time data analysis. And in this project, we are also having 5 different demonstrators for new innovative technologies. And one of the demonstrators I'm going to present here. And this demonstration sites focus on mainly 4 different industries, which is glass, copper, aluminium, and water treatment. Yes, so into the work package and methods. So basically in Trineflex, digital twins of demonstration sites are developed, and new pilots with novel technologies and technology synergies are introduced there, and from them also digital twins will be developed. And of course, with digital twins, you can develop universal models, and it's also then validated. And so with this, you can simulate technology integration in new sites. So you can see here mainly work package to focus on data acquisition to digital twins. Work package 3 is the integration of AI in the digital twin framework, and then work package 4 we are integrating the energy flexible technologies. So now to our task. It's a demo campaign consisting of a hybrid solar panel matrix, which is down here, and the heat pump here in the middle. And this is going to be integrated into CO2 capture plant, which is here in Trondheim in Norway. And this is shown here with the reboiler. So with the heat pump, we are upgrading low-grade heat from the PV panels or hybrid photovoltaic system to supply heat to the CO2 system in the reboiler. And so this is to showcase new flexible technologies and to analyze the synergy of the technologies. Partners involved in this demo campaign is SINTEF Industry, SINTEF Energy Research, and Svalin Solar. So how does it actually work together? The solar and heat pump assisted carbon capture and storage. Yeah, there's the sun. It's shining on our novel, or Svalin Solar's novel photovoltaic thermal collectors. Those are actively cooled, and this cooling is then provided by the heat pump, which takes the heat also collected by the PVT panels, upgrades it, and applies it to carbon capture and storage process. Now to the industrial excess heat recovery of the carbon capture and storage process. You have the piping diagram here on the right-hand side, where flue gas is coming in, then it's cooled before it goes into a absorber column, where it's absorbed, or the CO2 in the flue gas is absorbed in an amine solution. Then this rich solution is pumped to a desorber, where the amine is recovered and the CO2 is separated. And then you can pump the amine back to the absorber column. And in this absorption process, heat is released. And in the desorption process taking place in the desorber here, you need to supply the heat, which takes place here in the reboiler. So the energy released in the absorption process is actually equal to the heat that's demanded in the desorption process. But this equation here is a thermodynamic equilibrium, and actually the absorbed heat, or no, the heat released in the absorption is released at lower temperatures than the heat that needs to be supplied to the desorption. So this is why we have cooling up here at lower temperatures than we have the heat supply down here. And this alone is already a very good case to integrate the heat pump. But for our case, since this is carbon capture research plans, we will not integrate it in the market areas here, but only use flue gas cooled here. So we'll integrate a new heat exchanger to use the heat of the flue gas as a heat source, and not the heat of the absorption, which would be a better choice. But the plant is designed for research, so therefore integrating a heat pump here would take much more of an effort. But now I talked a little bit about the heat pump and mentioned it. What do they actually do? Heat pumps recover heat from low temperature heat sources and makes the heat usable at higher temperature levels. And this is done by kind of this thermodynamic cycle where you compress the vapor to a higher pressure, and due to pressure temperature relation, if you're at the higher pressure, you also have a higher condensation temperature. So you can release heat at the high temperature, then you can expand again, and at the low pressure you have lower evaporation temperatures, so you can take up heat in the evaporation process from your heat source. And this principle is shown here in the pressure enthalpy diagram, but also in the piping diagram to the right, where you have your evaporation stage going from 4 to 1, and the compressor here and condenser up here. So in Trineflex, we're implementing a butane high temperature heat pump. With a condenser with direct heat exchange between the butane and the mean CO2 mixture, which is here Caesar 1, and then containing CO2 and water. And also this heat exchange is quite novel, and this is all part of the investigation here. So then to the other technology integrated photovoltaic thermal system, which will be used at heat source. Here you can see the principle, the concentrated photovoltaic solar system that is concentrating solar radiation with mirrors, and focusing this on PV strips, which is then glued on pipes where you have cold water flow through them. Therefore, panels are actively cooled. Okay, and to give a short summary, Trineflex is a project that developed a digital toolbox with focus on transforming energy-intensive process industries. We saw that heat pumps are a way to recover heat from a low-temperature heat source and make it usable at a higher temperature level. We saw that the carbon capture process and in general absorption-desorption processes are very suitable process to integrate the heat pump for recover absorption heat and use it into desorption. But the same can also be done in the distillation columns. And we saw the new technology with it's called the concentrated photovoltaic thermal system here, which is innovative technology to simultaneously produce low-grade heat and electricity. And these technologies are combined in the demonstrator. This is which is currently in development here. That's it from my side. Of course, thanks to the EU for funding the project and also project partners that make it available. Thank you very much.